Hi everyone, welcome. We are going to look at the last video for this lesson. If you need this, most of us are going to need this one because this is getting into a really nuanced thing. And technically, it's probably something that you're only going to be dealing with if you're talking about like math theory and then linear algebra theory and stuff like that. So it's not something that you're going to really ever use in reality. And this is what's called classifying special systems. I only say this that you need to look at this because there's a couple must-do practice problems, and the ultimate goal for those must-do practice problems is more like really driving home the point of being able to like say whether or not you have one, no, or infinite solutions. Either way, classifying special systems is also going to be a part of this. So we have three different systems that we can have. We have systems with one or no solutions, infinite solutions, or one solution. And each one of these systems, let's like make a little table out of this. Each one of these systems has a little label that we can put to it. So we can say that we have one solution, infinite solutions, or no solutions with our various systems that we have. Say one, infinite, or no solutions. And if we look at each one of these scenarios, we can actually like draw a graph of each one. So I'm going to make little graphs here so you can see them all. And this table might be something that you would want to put on your note card for our test on this concept. And so our graph for a one solution system would have an intersection, right? We'd have a point of intersection where our points cross. This next one for infinite solutions, we'd end up seeing a single line on a graph because what we'd end up with is two lines that are right on top of each other. We have infinite solutions. And last but not least, if we had a no solution graph, we would literally have two parallel lines that never intersect. And we look at that. So if we looked at each one of these situations, we could say, all right, so for this situation for one solution, we essentially have lines that have two different slopes. That's all we need to be able to have an intersecting line. It's two different slopes. It doesn't matter what their y-intercepts are doing or anything like that. If we have two different slopes, they're going to eventually intersect, period. So these are lines with different slopes. This next one for infinite solutions, we need to have the exact same everything. We need to have the same slope and same y-intercept to be able to have a line that essentially is graphed right on top of itself. So same slope, same y-intercept needs to be the same for both of those. And last but not least, for parallel lines for no solutions, we would want to see the same slope, but we'd want to see different y-intercepts so we truly can see them consistently. Oops, let's actually write this out properly. Different y-intercepts. So we can truly see that they're not ever going to meet. Now, when we talk about each one of these things, I've left off the titles of each one of these categories that we have here. These categories all have different sort of parts to them that need to be explained and looked at. So let's now look at their titles. If we have a system that has any solution, that's not no solution. So we actually can say it has a point or it has infinite solutions. If there's any solution to it, we can say that those systems are consistent. We could actually pick out a point and say, like, this is a solution to this system. Now, there might be infinite number of those sort of situations for some of them, but there is a value or multiple values that we can take out of that. So we can call those consistent. Ones that have no solution is the opposite of that. So what's the opposite of consistent? Inconsistent. Now, last but not least, we need to be able to sort of differentiate between a consistent system because we have consistent systems that have one solution versus consistent systems that have multiple solutions or infinite solutions. Consistent systems that have one solution, we have two very different lines here. These lines are not dependent on each other. They are very independent. They have different slopes, potentially different y-intercepts. They are very different from each other. So we can call these independent. So they are independent lines of each other. They don't have any similarities necessarily at all. They could have the same y-intercept, but again, their slopes don't matter. Their slopes are different, so therefore they're independent. Consistent lines, so what's the opposite of independent? That have infinite solutions. Consistent lines with infinite solutions are not independent, they are dependent on each other. They're dependent in that they literally need to have the same slope and same y-intercept. So they depend, like the slope and the y-intercept depends on like being the same if they are the same. So we wouldn't get infinite number of solutions unless we had the exact same slope and the exact same y-intercept. So categorizing special systems. This is a table that I want you to copy down into your notes if you haven't already started doing that. Essentially a 3x3 table. You're going to draw 3 graphs. You're going to say 1 infinite, no solutions. And you're going to put these titles on here. And these titles, you have 1 test question for your exit pass, as well as you're going to see questions on the must-do practice problem saying categorize the system. This is what you're talking about. You need to be able to say if they are consistent and independent, meaning 1 solution. Are they consistent and dependent, meaning they'll have infinite solutions because it's the same line? Or are they inconsistent, meaning there's no solution at all because you have parallel lines, okay? So make sure you have this table written down so you can start working on the must-do practice problems. And whenever you're ready, take the exit pass. Thank you for watching. And you're done for this lesson after you take the exit pass. Bye.